In today's video, I'll be talking about a sum which deals with vectors at an angles, the same rope tension problems. So we have a ball which is being suspended to the wall at 30 degrees from the wall, and this will be our force Ft, and this will now be our force, the tension which is being acting on the ball. So the force due to the gravity acting on the ball is 10 newtons, which is downwards, and then there's another force F which is being pulled. So question A, how do you find the horizontal tension? So horizontal tension is just the tension which we are pulling. So that will be our force Fx. I'm going to give it a name Fx, a variable name Fx. And then now we use trigonometry. So since we can, you can keep the force, the pulling of the pulling force underneath the tension of the rope which was it to the wall. So if we keep that below that, it will be F is equal to sine 30 times Ft, because we know sine equals opposite by hypotenuse. So the opposite of the angle will be our pulling force, which is Fx, the horizontal force Fx, and Ft will be our hypotenuse side. So that's how we get Fx is equal to sine 30 times Ft. So now find a formula for the vertical component. For the vertical component, which is just the weight will we have to use the same trigonometry. So we know that the weight is being at the adjacent side, as you can see, because if you take the weight arrow, the vector upwards and join it to make it where it's being like joined to the wall, that conjunction would make that the weight as a 10 newton. So we have W equals Ft, the tension of the rope, the hypotenuse side, times cos 30 gives weight. So that will be our formula for the vertical component. Now moving on to part C, we have to use the second equation, which was B, to calculate the tension in the upper string. Since we know that the weight of the ball W equals 10 newtons, we can just substitute the values. So 10 is equal to Ft times cos 30. So Ft by putting the cos 30 to the other side, we'll get Ft is equal to 11.547. Rounding off to two decimal places will be 11.55. And for the D part, use your answer to C plus the first equation to find the horizontal force F. So now we have to just find the pulling force Fx. So that I'm going to keep it as, which from the first question from part A, we know that Fx is equal to sine 30 times Ft, the tension in the rope from the wall. So since we know the tension of the rope which is being suspended from the wall, we can just substitute the values sine 30 times 11.55, and we get the force as 5.77 newtons. And that's how we get the pulling force. Thank you.